to our re:Invent session, Governance and Security for an Organization of Any Size. I'm Andrew Black, I'm a product manager from AWS Organizations, and also in this session we have Raymond Ma, who is a product manager at AWS Organizations. During today's sessions, we're going to give a quick introduction to multi-account and why we use multiple accounts within AWS. We're going to talk about core concepts with multi-account management. We're going to touch on AWS Control Tower a little bit, along with the core concepts in multi-account management. Then we're also going to discuss 4 best practices for access and security. These are best practices that represent basic steps that any organization can take to improve the security of their organization. Securely manage your identity with AWS SSO. We're going to talk about managing access at scale with service control policies. We're going to talk about being able to monitor access patterns with Access Analyzer, and then also setting up security findings with AWS Security Hub. But before we get into that, last year during the security keynote at re:Invent, Stephen Schmidt said this: using AWS Organizations is the #1 place that your security team should focus. During this session today, we're hoping that you understand why that is the case, and hopefully by the end of it, you'll understand how AWS Organizations and using multiple accounts is a perfect place for your security team to focus to securely scale within the cloud. But before we start talking about organizations and multiple accounts, let's all baseline understanding of what an AWS account is. When we think about accounts, you might think of a Netflix account or an email account or something that's associated with a single user. When it comes to an AWS account or a cloud computing account within AWS, each AWS account is more of a resource container for multiple different cloud services. So within your AWS account, you can have multiple users, you can have multiple instances, you can have multiple buckets as well. An AWS account is an explicit security boundary. So within a single account, users don't have access to other accounts by default. As you create multiple accounts, each account is its own boundary. And so something that happens in one account doesn't impact other things in other accounts. It's a container for cost tracking and billing. Each account generates charges based on the services used within that account. And it's also a mechanism to enforce service quotas and API thresholds. As you're scaling in the cloud and you're generating more and more instances and workloads, there's a certain threshold that each account has. And so you might need to look into scaling across multiple different accounts. Over time, customers will add more accounts, and over time, you'll add more accounts as your cloud environment grows, as you take on additional applications and services. Accounts are an easy way to scale your business, especially as you're working across many teams. Working with multiple teams with differing needs, you can quickly vend new accounts so that teams can build custom environments and applications without impacting the existing accounts in your environment. You may have parts of your business that have specific requirements, such as country-specific regulations or compliance industry standards. You can build accounts that host your production workloads and apply policies within those accounts such that they meet the standard requirements of that industry. As you meet quota or account level thresholds, you can continue to scale and deploy resources across multiple accounts. Accounts provide a layer of isolation because they don't allow access to other accounts by default. In the event that one account is compromised or something impacts the workloads within one account, the issues will only be isolated to that account, not affecting the rest of your cloud environment. Now that we've talked about the basics of accounts and why we recommend you use multiple accounts to scale your business on the cloud, let's talk about AWS Organizations. AWS Organizations is the AWS service that helps you manage across accounts within the cloud. With it, you can easily create accounts and allocate resources to those accounts within your organization. You can customize your cloud environment by applying policies to groups of accounts, dictating allowed actions within those accounts. AWS works with a number of other AWS services to give you central visibility for your actions, security alerts, or auditing needs across accounts within an organization. You also get a single bill with multiple accounts. There are also some cost-saving services that work with AWS Organizations, such as Cost Explorer or Amazon S3 Lens, which help you identify resources within your account, view and investigate account costs, and find ways to optimize those costs. Now that we've discussed a bit about AWS organizations as a service, let's talk about some elements of an organization that you build using AWS organizations. We're going to run through this pretty quickly, but hopefully you can capture all the different needs and aspects and words that we're using to describe parts of an organization. So first, what is an organization? An organization, at its core, contains a root. It has management accounts, organizational units, and member accounts. It's a group of accounts that are managed by a single entity, and that's your organization. The organization root is the topmost node of the organization, and it defines the boundaries. All of the member accounts within your organization are identified within the root of the organization. There's also a management account within the organization. The management account helps you administer within the organization. Within the management account, you can create other accounts within your organization. You can create organizational units and policies. You can also activate services at the organization level. We generally recommend that you limit access to the management account because it has broad access within your organization. We're going to touch on that subject a little later in the demos with the security services, but generally you want to minimize actions taken in the management account to only administrative actions. We also have organizational units, or OUs, within the account. Organizational units are groups of accounts. It's a way you can categorize your accounts, but also when we talk about customizing your environment within AWS, this can be done at the OU level because you can define and apply policies at the OU level, which dictate actions that can be taken within the member accounts that are attached to those OUs. You can also provide separations between development stages, such as separating production workloads from development workloads within nested OUs. There's a lot of customizations that you can build within your organization using OUs. But let's take a look at what we recommend for how you can build OUs or how you can structure your organization. So let's talk about a common organizational unit structure that we recommend for all customers. First, you have your security organizational unit. This hosts the security accounts that your security engineering team will manage as they're managing the security across your cloud organization as you scale across multiple accounts. Typically within the security OU, you might have a log archive account, which hosts all the CloudTrail data, which logs all the actions from accounts taken within your organization. We also recommend that you have a security tooling account, which we'll come back to a little bit later in the presentation. This account is what your security team uses to manage the AWS security services that allow you to monitor your environment and investigate any potential security issues across your organization. We also recommend an infrastructure organizational unit. This hosts the accounts that help you with the infrastructure of your cloud. For example, you might have a networking account that manages all the VPCs or manages all the network connections for your environment, or it hosts your Exchange servers, for example. If you have any proprietary software information that's used internally with your organization, some of those workloads might be here in the infrastructure organizational unit. Typically, you don't have any customer-facing workloads within the infrastructure. We also recommend a couple additional OUs. For example, the Sandbox organizational unit hosts a number of different accounts that can be used by your developers or teams when they're testing out services or functionality. Typically, there aren't many policies applied here, as you want your developers to explore what they can build with the cloud services provided by AWS. And so these accounts are made for that purpose. They're typically separated from the internal network, but you also want to pay attention to the costs associated with those accounts. And then we have the workloads organizational unit. This hosts a number of different accounts that you will probably build, and this is probably the area where you will scale most in terms of the cloud environment. Because as you build additional applications or services, you can have separate accounts for each applicational service, and then you can also have separate accounts depending on your software development lifecycle. So for example, you might have an application A dev account, and you might have an application A production account, and these are separated by nested OUs. You can apply policies in your production OU that help protect your production workloads and ensure 100% uptime, where you might have a little more lenient policies when it comes to your development environments as your developers are developing products before they're pushed into production. So this is a basic organizational unit structure. We've gone over the organization, we've gone over this basic structure. Now I'm going to turn it over to Ray, where we're going to talk about some of the basic things you need as you're building your organization that allows your teams to have access to the things they need to and helps you to ensure that you have certain controls in place as you scale on the cloud.
Thanks, Andrew. Now we are going to talk about the identity, access, and security features that you'll want to take advantage of to govern your AWS environment. As we mentioned in the agenda, you'll first want to start with managing identity and access using AWS Single Sign-On. Next, we'll talk about using service control policies to manage permissions for your users. And finally, we'll introduce Access Analyzer and Security Hub, two services to help you get visibility and secure your AWS environment. Before we get there, I want to first introduce AWS Control Tower, our managed service that helps you set up a well-architected and secure AWS environment. It helps you roll out a lot of the baseline management capabilities, as well as works with additional AWS services. So in short, if you want an easy button to a secure AWS environment, definitely take a look at Control Tower. We're going to be talking about some of the underlying features that Control Tower uses so that we can go deeper into how those work for you. So back to AWS Single Sign-On. AWS Single Sign-On makes it easy for you to manage identities at scale. You can automatically update the users and groups to provision access based upon identities in your existing directory. And you can also manage dynamic permissions based on groups or security requirements. Let's take a look at how that works. So you start first with your identity provider. And Single Sign-On works with a native identity directory built into AWS Single Sign-On. It also works with AWS Managed Active Directory or any SAML 2.0 provider, including some popular ones like Okta, Ping Identity, or Azure Active Directory. Once you've connected your identity provider to AWS Single Sign-On, you will define roles and permission sets and then map them to groups and users in your directory. And once this is set up, you can then provision access to your AWS accounts. Next, we'll go ahead and walk you through a demo of AWS Single Sign-On so you can see how this works firsthand. So I'm here in the management account of my AWS organization, and the first thing I'm going to do is to go ahead and enable AWS Single Sign-On. The next thing we're going to do is to change our identity source. And so I'm going to switch away from the AWS SSO default directory to an AWS Managed Active Directory because I already have existing users and groups defined in this corporate directory. So I'm going to go ahead and type accept here and then change identity source. The next thing that I'm going to do is we're going to create permission sets, which will specify the permissions that we're going to be granting to users and groups. So I'm going to go ahead and navigate over here to AWS Accounts, Permission Sets, and then create a permission set. The first permission set we're going to create is an administrator access permission set using the job function policy that we will be assigning to our administrator group. The next permission set we're going to create is a systems administrator permission set, which we will assign to our developers. Now that we've created these two permission sets, we're going to assign groups to accounts. So we're going to come over here, and first I'm going to select all of the accounts in my organization to assign administrator access for my administrator group. I'm going to go over here and look for my administrator group, and then go ahead and give them the administrator access permission set. Now that that's all complete, I'm going to go ahead and assign the systems administrator permission set to our developers, but I'm going to exclude them from being able to be assigned permissions from the management account. I'm going to look for my developers group, and then go ahead and assign them the correct permissions. Systems administrator. Now we're going to go ahead and test this out to see if my users have the right permissions to access the right accounts. So I'm going to go over here to my dashboard, and then we're going to open up the single sign-on user portal. So first, I'm going to sign in as myself because I've previously added myself to the administrator group. I'm going to try that one more time. And now here you can see in the user portal, I have access to all 6 of the accounts in my organization, and I have the ability to sign in with administrator access in any of these accounts. So I'm going to go ahead and test and see if I can sign in with administrator access to my management account here. And it looks like that works. So we're going to go ahead and go back to the user portal, and I'm going to sign out and then sign back in as a developer. And so I've given Andrew access as a developer in my developer group in my directory. So I'm going to go ahead and sign in here and see if he has the right permissions. So you can see here he's been granted access to 5 accounts. So all of the other 5 accounts in my organization, except for the management account. And he has the systems administrator role to sign in. So we're going to go ahead here and attempt to sign in to the account 1 in my organization. You will see there, Andrew is able to sign in successfully with the systems administrator role and access the account 1 in my AWS organization. And that's single sign-on. Now that we've set up identities and access to AWS accounts in our organization, we'll want to define guardrails for what users can do in these accounts. For customers to do that, we have a feature called service control policies. With service control policies, you can create guardrails around what services and actions that users can perform in accounts in your organization. This promotes increased agility because you no longer need to manage so granularly at the user and role level. And these guardrails can be assigned at various levels of the organizational hierarchy to easily define the same guardrails across similar accounts. As Stephen Schmidt said last year at reInvent, service control policies will make your life better. So let's dive into the details about how they work. Service control policies define what any user or role in an account can do, regardless of what permissions they have been granted. Take, for example, this service control policy that says no principal is allowed to perform the leave organization action and remove an account from the organization. This means that even if someone is signed into that account using root credentials, which have full permissions to the account, they will be prevented from making the account leave the organization. Service control policies can be applied at various levels of the organization, and lower parts of the hierarchy inherit the guardrails that have been defined above them. This allows you to define broad guardrails to apply across your organization at the top of the organization hierarchy, and then get more specific in your restrictions further down the hierarchy to affect different levels. Service control policies do have a broad set of implications to the API actions and services, so we don't want to apply them directly to the organization without testing their intended behavior first. In our recommended organization structure, customers should define a policy staging organizational unit where they attach service control policies first and test to ensure that the behavior matches what is intended. You can even build out nested organizational units and additional accounts underneath them to better reflect your organization structure and test the effects of a combination of policies attached at different levels. There are a multitude of use cases for service control policies across a customer's organization. And here is a list of popular use cases that customers have implemented on their organization. We're now going to go ahead and show you what two of these examples look like, which include limiting regions available to users and preventing default encryption from being turned off. The first service control policy example we're going to talk about today is this deny all regions except EU policy I have already authored. So what this policy does is it prevents users and roles from accessing all AWS regions except for the European Union regions. Let's take a look at what the policy looks like. So the first thing that you'll notice is that our effect for this policy is deny, and then we have a not action section. This not action section contains a list of global services which have endpoints in the US East 1 region. By having this not action here, requests to global services in the US East 1 region are allowed, but all other services in US East 1 are denied. Down here at the bottom, the condition element has two parts. We've got a region list and then exempted principals. The requested region lists all of the regions that should be allowed. In this case, all 6 available European Union regions that AWS currently offers. In the are not like condition element, we've exempted the following principals from this SCP. In this case, we're exempting all AWS single sign-on users that are signing in with the administrator access permission set. Now let's go ahead and attach this policy so we can see what that looks like. So I'm going to come over here to my policy staging organizational unit and attach this policy so I can test it before rolling it out across my organization. Now that we've attached it, I'm going to go back to AWS single sign-on and sign in to that account underneath my policy testing organizational unit with a non-administrator access user. So in this case, I'm going to select systems administrator. Now, I can currently see that I am in the US East 1 region, and so I'm going to go ahead and try to launch an EC2 instance here. So you can already see there are some API errors which might give you a clue that certain API actions are being blocked. So let's go over here to instances and launch a new instance, and I'm going to select this first one, Amazon Linux 2 AMI. And what you'll see here is that an error has occurred describing your select AMI, which means I'm not authorized to perform this action. Now let's go back to single sign-on and see what this looks like when I use an administrator access user. So I'm going to come back over here, and then I'm going to sign in with the administrator access user and take a look at what that looks like. So I'm going to navigate to EC2 again, and then I'm going to attempt to launch an instance. In this case, that does work, and then I'm going to go ahead and just attempt to launch an instance. And what you'll see is that my instance was successfully created, which means I'm currently not blocked by that policy. Let's go back to the system administrator user and then try it again in a EU region. So I'm going to go ahead over here and switch over to Frankfurt. And then I'm going to attempt to launch that same EC2 instance. As you can see, I'm now able to launch an instance because I'm currently in one of the European Union allowed regions. Now we're going to go ahead and take a look at the second example I have for you today. So let's go back to our management account and then navigate to organizations and go to our policy list. So the second example we're going to talk about today is this deny S3 encryption modification policy, which prevents users from modifying S3 encryption settings. If we look at the content of this policy, you'll see that I'm currently denying an action, which is S3 put encryption configuration. Once again, in the condition elements, I've gone ahead and exempted the SSO user using the permission set of administrator access, so administrators can still bypass the service control policy. Let's go ahead and take a look at what that looks like again on my policy staging organizational unit. So I'm going to go ahead here, and first I'm going to detach the previous SCP that we were testing. And then I'm going to go ahead and attach my S3 encryption modification policy. And so what I'm going to do next is I'm going to go back and sign in to my policy test account that's underneath that policy testing organizational unit. I'm going to select the system administrator user here. The next thing I'm going to do is navigate over here to S3, where I have an already created bucket. And what you'll see in the properties for this bucket is that my default encryption is currently set to enabled. I'm going to go ahead here and try to change that to disable. And what you'll see here is that I get an error message that says I don't have permissions to edit the default encryption settings, which is by design from our SCP. Now I'm going to go back to SSO and try to do that with an administrator user. So once again, I navigate over here to S3, select that same demo bucket, and then we're going to try to modify the encryption settings here. As you can see, as the administrator access user, I was able to successfully modify the encryption settings. And that's our demo of service control policies.
Now we're going to discuss a little bit about monitoring access. We've provided access with SSO. We've talked about being able to manage some of the actions within accounts with your policies. Now, once you have all of these in place, you want to continually monitor what's going on within your organization. And this is where we start to talk about some of the security services that are available, which help you or your security engineers. It helps you monitor what's going on within your organization, helps you be able to audit the access that is provided within your organization. And so let's talk a little bit about IAM Access Analyzer. IAM Access Analyzer provides a number of features for helping simplify access analysis. First, it helps simplify access analysis. When you author policies, Access Analyzer helps you to check and validate your policy. And it provides functional recommendations that can be added to your policy that improve security. It also helps you scale permissions management. As you create resources and policies, Access Analyzer can generate findings for resources with permissive policies that allow access outside your zone of trust. Access Analyzer works at the account level, so users within the account can identify resources with access from outside the account. It also works at the organization level, so you can identify resources that allow external access from outside of your organization. You can also generate policies with Access Analyzer. Access Analyzer can review access patterns from users or identities within a specific date range using your organization CloudTrail. And then you can generate a policy that reflects those patterns. This helps you author policies that encourage least privileged access within your organization, helping improve your organization's security. We're going to talk a little bit more about how this works at the organization level, given that we're talking about scalability and being able to manage permissions at scale. And so we're specifically going to focus on the area of Access Analyzer that allows you to identify resources that may have permissive policies. Access Analyzer can identify resources within your organization, and it evaluates the policies within those resources. If there are any policies that permit access from outside of the organization, from an external entity, it provides you a list of those resources. And so you can quickly see which resources have permissive policies that allow access from outside the organization. This helps you simplify identity and helps you mitigate unintended access to the resources. We're now going to show a demo to show you how this works in an organization environment. We're going to enable Access Analyzer at the organization level. And then we're also going to talk a bit about how you delegate administration of Access Analyzer to your security tooling account that we talked about earlier within your organization.
In this demo, we're going to enable Access Analyzer at the organization level, and we're going to delegate administration of Access Analyzer to one of the member accounts for our security team. Let's take a look at our organization. Within our organization, we have a number of different OUs, similar to what you would expect to see in a production organization. Let's take a closer look at our security OU, as this is where our security team has accounts that they use to monitor access to our organization and also to check any security findings from any of the AWS security services or other security services that they use. Within the security OU, we have nested OUs to separate the development and production environments. Within our production environment in the security OU, we have a log archive account, which hosts all of the log data from CloudTrail and other services so that our security team has access to it. We also have a security tooling account. This is the account that our security team uses to manage security on behalf of our organization. There are a number of different AWS security services that allow you to delegate administration of those services to a member account, and we recommend you do it to this security tooling account. Those services include AWS Config, IAM Access Analyzer, AWS Security Hub, Amazon Macie, and many others. Currently, we're in the management account of our organization, which is why we can see all the organization data. The management account has broad permissions. With the management account, we can add accounts to our organization. We can create and add policies to our OUs or to our accounts. And we can also enable services at the organizational level. Because the management account has such broad permissions, we recommend where possible to designate a member account to manage services on behalf of the organization. This means that they have an organization-wide visibility for that service without having to access the management account. In the case of IAM Access Analyzer, we're going to designate Access Analyzer to the security tooling account. Let's go to IAM. I'm going to copy the security tooling account since we're going to be using that to designate use of IAM Access Analyzer at the organization level. We can go to Access Analyzer on the left. We can see that it gives us the option to register a delegated administrator for this service. IAM Access Analyzer allows you to monitor access to resources within your organization. Access Analyzer will take a look at your resources and provide you with visibility of resources that have permissive policies that allow access from outside a zone of trust. In the case of an organization, the zone of trust is the organization. Let's go ahead and add a delegated administrator now. Let's add the account ID for our security tooling account. And it's that simple. We've now designated that security account as a delegated administrator for IAM Access Analyzer. Let's go ahead and switch to that account now. Let's assume that we're a security engineer and our administrator has just given us access to Access Analyzer at the organization level. When you create an analyzer, we can see in the options that we now have an option to select the organization as our zone of trust. This means that this analyzer will use our organization as a zone of trust, and it will identify any resources within our organization that allow permissions from outside of our organization to those resources. So let's go ahead and create this analyzer using our organization as the zone of trust. Once we create the organizer, it takes a couple minutes for findings to show up. We can see that our analyzer is now active. Let's see if it has any findings. You can see with these findings, it's already found a number of resources that enable access from outside the organization. It quickly gives us a view of which account hosts those resources and which external principals have access to those resources and in what ways they're able to do so. Let's take a look at one of the findings. Within the finding, it gives us a resource for access. it identifies what access level they have, in this case assuming role and tag session. Let's take a look at another finding. But this finding, it looks like there's a demo in here that provides read access, and it tells you what level, that at the get object level. That means that an entity, all external principals looks like, have access to this resource. Let's assume this is a static website. This might be something where we intend people to have public access, and we can archive this rule if that's the case. But let's assume that this might be a bucket of customer information in one of my workloads accounts. If this is a bucket, if this is an S3 bucket that contains customer information, that's definitely not something that I would want external visibility from. And so I'd want to go work with the account owner or go to the resource itself and modify the bucket policy to address the access level to ensure that it can only be viewed from accounts within the organization. With Access Analyzer, this helps focus your security team's time and effort toward potentially concerning access levels with resources within your organization. And it provides all of those findings here in a single window. And because the security team is managing this within their own specific account within the organization, they have access to organization-wide level without having to access the management account.
We hope you enjoyed the demo from IAM Access Analyzer about enabling the service at the organization level and also being able to delegate administration of it to a member account within your security team. We're going to show you a similar example using a different AWS security product, Security Hub. Security Hub provides you a single location where you can get all of the security findings across multiple different services within AWS. It essentially gives you a single pane of glass for your security team to review security findings and investigate further. Each of the services that are compatible with Security Hub, typically they operate within the organization level, or a number of them operate at the organization level. And then Security Hub itself is able to take all the findings from across all of your member accounts and put it in the same place so that your security team can quickly identify potential concerns and address them. This helps reduce the strain on your security team, helping them to focus on prioritized needs. You can see a number of different AWS security services that are integrated with AWS Security Hub, such as Amazon GuardDuty, AWS Config, IAM Access Analyzer, which we just discussed. And then there's also other third-party security services that are available that are also incorporated with Security Hub, where you can activate subscriptions and their findings can be brought in along with all the other security findings from the AWS service. Again, helping your security team to identify potential concerns within your cloud environment that should be addressed. During the demo, we'll go a little bit deeper into what this looks like and some of the findings that you can get from AWS Security Hub and how this operates at the organization level. Let's take a look at that now.
In this demo, we're going to enable AWS Security Hub at the organization level. We're going to register a delegated administrator for AWS Security Hub. And with that delegated administration account, we're going to enable Security Hub across member accounts of the organization. In our previous example with Access Analyzer, we showed you how to do this within the console. In this example, we're going to show you how to do this via CLI. First, we're going to delegate administration of AWS Security Hub to the Security Tooling account. This is the same account that we use to delegate administration to Access Analyzer. We recommend that you use a Security Tooling account as a delegated administrator for all of the AWS security services that you use. We do this by using the Enable Organization Admin Account command from Security Hub. And then we need to add the admin account ID, and this is the same as the security tooling account that we used before. Now registered this as the delegated administrator for Security Hub. We can check and make sure this is the case. We do this by using the list delegated administrator command from AWS organizations and defining the service as Security Hub. We can see that the security tooling account is the delegate administrator for Security Hub. Before we leave the management account, we want to enable Security Hub on the management account. When you delegate administration of Security Hub to a member account within the organization, they can enable Security Hub for other member accounts within the organization, but the management account still needs to enable Security Hub within the management account if the security tooling account is going to have visibility into findings from Security Hub from the management account. So let's go ahead and enable Security Hub. It's now been enabled within the management account. We're now going to switch to the console, and we're in the security tooling account from our organization. AWS Security Hub is a very visually centric product where it provides you with a number of different security findings in a single view, and so we want to be able to display that view using the console. You can see that the member account has already been registered as the delegated administrator for the organization, which we just did. We can now enable Security Hub within the security tooling account of the organization. So let's go ahead and use all of the standard defaults and best practices, and we'll come back to this once Security Hub is enabled. We can now see that Security Hub is enabled. Let's go to our settings so that we can enable Security Hub across member accounts within our organization. You can see within the settings, we have a number of different accounts listed within our organization. Some workload accounts, our log archive account, a network accounts, and also our management account, because we enabled Security Hub in the management account. We can select all of these accounts, and we can add them as members to our Security Hub. What this does is this enables Security Hub within the member accounts, and then we also are able to see the findings from Security Hub within our overall view across the organization. We've now switched to a different account within a different organization, but this is more representative of what you might see in a production environment, whereas our previous account was just a demo environment without too many workloads. You can see within Security Hub there are certain standards where you can get scores based on your security findings and how compliant they are with those different standards. And you can enable or view or disable the results from any particular one of these benchmarks. We can also see insights where it helps us identify cross-region security alerts and the potential concern that they have. Again, this helps your security team focus on areas where there is most concern and where they can have the highest impact to secure your environment as you create new accounts and as you scale across different resources. You can see that it looks like there's a number of buckets here that have public access. These are similar findings to what we saw in IAM Access Analyzer, but these are brought with a number of other different security findings from other security services, and so you're able to see an aggregate view of all of these. You can see within the integrations all the different AWS security services where their findings can be seen in Security Hub, like Audit Manager, IAM Access Analyzer, Firewall Manager, Amazon GuardDuty, Amazon Detective, and many others. There's also third-party services that are integrated with Security Hub, and so if you work with these services or if you enable subscriptions with these services, those findings can also be imported to Security Hub, so you can have that single pane of view for all the accounts across your organization. We discussed Security Hub in our presentation and in this demo because of this integrations aspect. Once you enable Security Hub, it gives you a number of different services that you can enable that help bring your findings into the same single pane of glass. And so we recommend it as a great starting point to identify potential security concerns or help you identify other services that can give you more information that help you to secure your environment as you grow and scale on the cloud.
So let's recap what we've talked about today. So AWS Single Sign-On enables you to manage identities and access to AWS accounts in your organization. You can set permission guardrails for what users can do in accounts using service control policies. You can use IAM Access Analyzer and Security Hub to increase your visibility and security. And we introduced the concept of Delegated Administrator that enables you to isolate the management of multi-account services to other accounts in your organization for managing access. So enterprise customers have been very successful in taking advantage of these features to help manage their organization at any scale, all the way from small startups to Fortune 500 companies. The capabilities to manage and operate your AWS environment scales with the needs of your business. And we look forward to continuing to provide new features to make it easier and more capable for you to manage your environment on AWS. So thank you for joining us on this session of Governance and Security for Organizations of Any Size.